Good morning, everyone. Today we have a special guest. We have David from Prelude that is actually going to do kind of a part two on the Prelude product. For those of you that actually didn't watch the video, we kind of realized that the previous video was recorded a year ago, so time flies, that's for sure. I guess he's going to do an update on some of their offering and some of the cool things that you can do with the tools. So I guess without further ado, David, the floor is yours, so it's your show.
Perfect. Well, thank you very much. I'm honored to be back again. I had a really good time. So a couple of us actually from Prelude gave the talk last year, myself included. And we had a blast. We enjoyed it. Got to meet all you guys. So thanks for having us back. So my background in a quick nutshell. So I lead the technical teams here at Prelude, and most people know us through the tool that is called Prelude Operator, which is a command and control type of tool that's really geared toward right down the center purple teamers that are trying to do manual to semi-autonomous assessments. So it's not a specific red team tool where you're trying to evade everything, but it's not a blue team detection engineering tool. It fits in that middle gate of putting a lot of power in people's hands that they can pull off TTPs with a pretty autonomous type of nature. Without a tremendous amount of effort or overhaul and setting up infrastructure and so forth. So most people know us through Operator. Before Operator, I'll just flip down a slide or two. So before Operator came out, I worked at a handful of places over the last 15 to 20 years. The last one being MITRE Corporation, which a lot of folks know through MITRE Attack. I was on the attack leadership team, and I wrote a tool called Caldera between around 2017 and 2020. Caldera was kind of the precursor to Operator in a lot of ways. Purple team tool that was born out of the U.S. government's research departments as basically at a time period when the government was looking for an autonomous hacker and looking for research concepts. There is kind of how Caldera grew up and got into the world. Open sourced the framework, the version 2 of it in 2019, and that really in a lot of ways led it to the work that we're doing now with Operator. These tools so prior to that, I worked at places like Mandiant and FireEye and John Deere and a handful of places within the U.S. government over the years, always doing offensive cyber ops and that sort of background. If those of you wondering kind of which type of background I come from. So a lot of these tools that I've been involved in over the last couple of years, such as Operator and Caldera, are, while they're different and they have varying levels of what I'd say production capabilities, Caldera being a research project, Operator being a much more productionized, polished version that you can take into the field. What they all have in common is that they are tools that are intended to make a purple teamer's life easier, better, faster, more consistent, more reliable. So it's all about shaping the workflow of the purple teamer. Now, I've watched the industry, and our team at Prelude, we've got a variety of very experienced folks here. We've watched the industry kind of evolve over the last couple of years, and we're trying to see, well, where is the security industry actually going? Where does it need to go, and where is it currently kind of trajectory-wise going? And what we've been watching is the evolution of Purple Team as it kind of came into popularity in the mid-20 teens. Call it 2015, purple teaming kind of came up as a new position, eating away a little bit of the red team budget out of that part of the organization. And it really popped up as hey, this is a needed position because red and blue teams need to communicate. They're not communicating very well. It needs to communicate, so let's invent a purple team position that can run that kind of communication between the two. Over the next couple of years, between around that 2015 to 2018-19 timeframe, a variety of organizations popped up in the breach and simulation, or the BAS space. And so nowadays there's like 10 or 15 companies that exist in that space, and their goal has always been, hey, let's automate the red team process. Now, the BAS industry has never really been able to pick up in terms of mass scale or becoming a really big part of the cybersecurity industry. It's always been like a third tier type of part component of the industry, as if you will. If you think of things like threat intelligence, and maybe red teaming as first order priorities, something like BAS vendors tend to be at that third level. And a lot of different reasons for that, but it's that industry has had a hard time breaking through and becoming a really important or very impactful part of cybersecurity. And we've kind of watched that happen as we're, at Prelude, we don't consider ourselves a BAS vendor by any stretch of the imagination, but we've kind of watched it because a lot of people that use Operator actually come to us from BAS vendors that are unhappy. And so as we've onboarded a variety of companies, really dozens of them at the end of the day, and hundreds of purple teamers onto Operator from different BAS vendors, we've spun up all these conversations and tried to realize, hey, well, what are you doing? What are you unhappy with? And where does this industry seem like it's going? And here's an architectural overview of the two tools, Caldera and Operator in our case. And really what we've come down to realize is we need to create a better pathway to make security work, meaning red and purple team work, more impactful at an organization so it can start to become more of a first order priority for how an organization handles security. The one thing I've noticed, especially in the last couple of weeks, is with all the tech layoffs that have occurred, and a large number obviously hitting tech departments and security departments in particular, one common thread I've noticed is purple teams in particular are starting to get hit the most and distributed across either the red teams or things like SecOps or operations or even DevOps in some cases. And that seems to be the trend. And I think that's just a sign that organizations aren't putting enough priority or impact or importance on the work that the purple team is doing and trying to accomplish. Now, when I want to shift the gear into like what we think can start to move the needle on that importance and impact. So,
hey David, do you mind just making the slides full screen so we have better visibility?
Yeah, absolutely.
Thank you, sir. And someone asked, why do you think that is, like, purple team being laid off from your perspective?
Why do I think it?
Yep.
Yeah, so I think they're generally getting hit first right now because they're looked at more of like a research role than an actual like making the organization safer role. And so if you compare, say, a purple team to SecOps or IT operations that is like managing EDR and AV and so forth, that I think has a larger spend on the budget, and people look at that and say, oh, this is directly tied to security of the organization, and purple teams have a hard time breaking through into that objectivity.
Makes sense. And do you believe that tools will actually, replace human in the whole purple team area?
Yeah, that comes up a lot nowadays. I think eventually we'll rely more and more on tools. I think there's always going to be a human element, regardless of whether we're talking red or purple teaming. But I do think that the human control and human in the loop is always going to be part of that, at least in the foreseeable future.
Makes sense.
Yeah, so when what do I want to say, maybe a couple months ago, we launched a new concept called the VST. And this is really a few months ago, we started to realize, hey, we want to elevate what a purple team does, and even a red team to a large amount, and take their role in an organization and start to elevate it to a higher degree of importance to the org. So the work that they're doing isn't just inside of their org or their small team, because, red and purple teams tend to be pretty small, but is actually felt throughout the organization. Now, how could we make the purple teams work that big? So as we started to unpeel that onion, if you will, we came to a few conclusions as far as why purple teams and red teams aren't capable of, say, running their TTPs on all the machines within an organization or large subsets of them. And so we created a concept called the Verified Security Test, or VST. Now, a VST, in simple terms, you can think of as a production version of a TTP. So take any TTP that you get, which nowadays is a very conflated term, but we're familiar with things like Atomic Red Team TTPs, we're familiar with Caldera TTPs, Operator has TTPs, You could even pull random payloads off of exploit DB, wrap them in a script, and call that a TTP, right? So a TTP in red terming may not go under that acronym, but it may just be a payload. It could be a TTP. Now, red teams and purple teams use these things in order to create effects on systems and to laterally move and dump creds and all sorts of things. The problem with TTPs and payloads in general is that they are what we would call from Prelude, we call them unverified. These are things that could cause real harm if not handled appropriately. Now, for us to be able to really scale up, the importance of a red or purple team, we wanted to create a version of a payload or TTP that is completely safe to run. If you're running it on one machine or 100,000 machines, if you're in a dev environment or a production environment, we want to take the context of how you run it out of the equation and create a completely safe version of itself. So left-hand side, you can see a typical TTP that we grabbed out of, this one's actually an operator and Caldera, similar format. And then you can see on the right-hand side a version of the same thing that is in VST format. Now, the real big difference here outside of the language is the fact that every VST is a compiled Go binary. Doesn't need to be Go, but we use Go internally. It needs to be a compiled binary so we can actually sign it and execute it consistently. And so you can see here we've got a test function and a cleanup function that's attached to each VST. This gives you the ability to execute a test in the test function, which is the default if you just, ran the executable without any parameters. And then there's a cleanup function that can run at the very end of the test to reverse the effects of any test. The VSTs on their own aren't more safe or verified than a TTP per se, but the process of compiling it and creating consistency and being able to put it through test rounds that are very consistent allows you to create an ecosystem of these payloads, if you will, that is highly unlike anything in the world of TTPs today. This is part of what makes them consistent is the exit codes. So with a TTP, if you were to run it on your machine today, pick a payload or any TTP, you run it, what happens is your console is going to dump out some arbitrary text. So for example, if I wanted to dump credentials, pull out a handful of tools or maybe do an AD find in order to locate some stuff on the disk, I'm going to get a bunch of text that pops onto my terminal that is the red or purple teamer. I need to take my knowledge of the industry. I need to read the material that prints the console, and then I need to mentally parse it in order to figure out A, what it means, and B, where do I go from here. So maybe I run AD find in order to locate a domain controller, and then I want to utilize the information I see because I know I can use that to attempt to laterally move or mess with it in some form. Now, that's a lot of context and not infinite, but a large number of different commands that can be strung together to create different behaviors and scenarios. Now, a VST controls this and kind of takes the context away from the security person, so you don't need to sit there and contextualize everything. Every VST exits when you run the binary with a code off of this list. These are actual exit codes, and we manipulate some of the codes and direct them to be specific numbers that we've created that show the granularity of what occurred in the test. So, for example, if you were to run a VST and it exited with the code of 100, that is this test ran and it was a good thing. The result was good for you, as expected good. If you got an exit code of 101, that would indicate that the test did complete as intended, but it is showing that this thing should not have been allowed to run, and it did. And so we've developed, 20 or 25 of these codes that describe very detailed level of granularity, what occurred within the test. And you can manipulate that as the test author as you're setting these up. But this allows you then to run a test, don't care about the text arbitrary output, only focus on the code, and it allows you to understand what occurred across a large number of your devices, endpoints, workstation servers, what have you, wherever you're running tests, aggregate them together, and you can understand a larger picture of what occurred. I'll jump into this in a bit, a little bit of Visual Studio integration when I show the code. And I'm going to skip over a couple of these because I wanted us to get a little bit more into the code to make sure we have plenty of time for that. All right, so when you think of command and control, you've got really three components. You have an agent, you have some version of a test or a TTP, and you have a control center. So if you look around the ecosystem, you look at different tools, you tend to break things into those three categories. In Operator, we've got agents and a desktop C2 and the idea of TTPs, right? All the different tools kind of follow a pretty similar methodology. Now, what we've developed along with the VSTs, which is our version of the TTP again, the production version, instead of agents, we've developed a concept that we're referring to as probes. Now, we switched from the terminology agent for a reason. Agents come with all sorts of bad connotations. Largely, they're enormous. They eat up resources like crazy, and they're generally hard to work with. We went with the term probe for what we're doing because they have a lot of unique characteristics that we think are unusual in the industry. So our top two probes that we generally recommend running and we run in production ourselves are called Raindrop and Nocturnal. Now, what's cool about these is these probes hover around a kilobyte in size, which is very, very tiny. And so what they act as are basically encrypted communication channels that can connect back to your control center and get tests to run, and then execute the tests after verifying that they are okay to run. They have safety mechanisms built into this 1 kilobyte. They verify that they're the right test to run. They execute the test. They gather the status codes that the test may generate, and then they ship those status codes back to the C2 where they go into an aggregate system. And so these things are tiny. The other really cool thing with these is they require no special privilege. You don't need to install them, so they have a very light footprint. They use up basically no system resources because they are doing nothing when they're not connected. And we wrote them in common shell languages, Bash and PowerShell, including zero external dependencies, so they can run on a very wide array of machinery. So basically any Linux, Mac, and Windows, these things are good to go, and a variety of OT devices that we've already run and tested them on. Now, Bash and PowerShell, if you are on the red team side, you may try to veer away from, because these are pretty heavily detected nowadays, relatively, I'd say. The reason that we're opting to write it in these, aside from the size, is we are trying to make a stance with the probes to remove the agent itself, or the probe in our case, from being part of the assessment when you run a purple team exercise at scale. So as we've learned this through Operator and Caldera and so forth, when you include the agent as part of your security assessment, meaning the defense can hunt for the agent and try to shut it down, what happens is you end up in a game of whack-a-mole, which doesn't scale very well, which means the defense will find that, hey, this process is tied to this binary, that must be the agent. Let's go ahead and clear out that agent and delete that file from each one of the boxes. Purple team goes back, they scramble the hash of their agent, they drop it back on the boxes, and kind of you're at it again. That works in small assessments. That doesn't work as you scale up from 5-10 machines to hundreds or thousands. And so our goal is to have defenses, including human defenses and technology defenses, focus on the behaviors of the tests instead of trying to hunt for the agent or the probe. And so as the probes run tests, what they do is they actually spin them off in separate child processes. And we coach people, both, again, technologies, EDRs and AVs, as well as people, that they should hunt for those child processes and see if you're able to locate what's occurring and shut those down. So those are a couple of the unique characteristics of the probes. All right, the last thing I'm going to dive into before we switch gears and hop out of the PowerPoint is a concept called rules. This is the third and hopefully last thing we invented in terms of new concepts here outside of probes and VSTs. Rules are it's kind of an old way, but a new way, it's coming back, I think, of analyzing how secure your environment is from an endpoint level. Now, a rule is basically a statement of fact about your endpoint that should never be broken when it comes to security. So, for example, our very first rule is that endpoints should quarantine malicious files. So that's a rule that should never be broken. It relates to the surface area of an endpoint, and you can write a VST that can test whether the endpoints inside of your organization, servers, workstations, what have you, are capable of abiding by this rule. And so we've already developed a number of these tests, VSTs, that are coded to this rule, so quarantining malicious files. Now, what we've done is on a weekly basis, we actually create new ones and we put them open source in our GitHub repo. And what we do is we defang a current malware sample that is starting to gain traction in the world. We defang it, we wrap it into a VST, and then we deploy it out to all sorts of different environments. And we measure whether defenses are capable of catching known signatured malware as it drops to disk. It does nothing else, just drops to disk. And if they're not, and the results that we've seen are shocking in a lot of ways. We've got a couple other rules on screen here. Enforcing firewall. We would expect every endpoint to be capable of doing that. Same thing with protecting device information, sensitive info, physical locations and addresses and that sort of thing that a device may have access to. So we've developed about a dozen or so of these rules that we consider true statements about endpoints that should never be broken, but are also very easy, relatively, for a security team to test to make sure that is the case. So I'm going to pause here real quick. Questions so far?
All good on my side, and the chat is also pretty quiet. But I guess it was actually pretty clear, to be honest with you. And I really love the fact that you can actually, have scripting layers on top of it. And as you mentioned, even those code are integrated in the product, but you can also kind of define them on your own with whatever you do, right? Which is nice.
Totally. Yeah, totally. Yeah, so if you
I
guys
have a quick question, if I may.
Sure, go ahead.
Yeah. If you were to deploy this in a large organization, let's say like 1,000 endpoints, like when you work with the client, would you like give them like a way to deploy the PowerShell script? How would you go about that?
Yeah. So I'll actually show this on screen. So I'm actually pretty proud of these. Our docs are pretty robust. A lot of places are not as much, but we put a lot of attention in these. So I'm going to head into our deploying probes section. And probes can drop onto machines two ways: ephemerally, which no installation, no anything, you just run them kind of like a script. These are more geared toward the purple team side of deployments. And then you've got persistent probes, which is much more like, hey, I want to drop this on 1,000 computers and I want to do it in a more traditional sense. And we work with companies on this, which is, hey, 1,000, 10,000. We're actually working on one that's 50,000 right now. And I want to drop these on 50,000 machines, and I want it to test to ensure that our EDR is always working as we expect it, which is what we found a very common request. And so we've developed traditional installers, MSIs, packages, deb repositories, and so forth. So you can actually install these as a service on any device if you want it to run persistently and always be there.
Pretty cool. Thank you.
Yep. And so I'll speak of this real fast because we're kind of in this area. I mentioned the EDR work. So we work with different EDRs, CrowdStrike being the one that we have the tightest, I'd say, relationship and integration with right now. So when you deploy this out and say you've got CrowdStrike running or available in your environment, you can actually deploy these probes out side by side and connect the two, which means that every time that we run a test or you run a test against your probe and CrowdStrike Falcon, the EDR does not catch it and it should have caught the test, that information can feed into your CrowdStrike account and it can train the CrowdStrike EDR to be better at catching that type of thing in the future. And that's a pretty cool integration. We're hoping to start pushing that pretty heavily because we think if you can do a full circle integration like that, and we can get purple teams writing mass amounts of these tests that are constantly kind of, batting down the EDR and trying to find ways around it, and that information can automatically get fed into the EDR system, so it can try to learn from that and get better. We can start to create a cycle that allows us to really measure very objectively, and I'd say impactfully, the efficacy of each one of these EDRs.
Are you going to expand out beyond CrowdStrike to other EDRs?
Yep, 100%. Yeah, CrowdStrike was our first, and you can kind of read about it here. This was our first integration point about how to attach it and kind of how it works. But yeah, we're working on a number of other integrations. So if you end up having one top of mind and are curious, let me know, and I can kind of let you know where it is on our side, and we can fast track stuff too.
Cool. Thank you.
Yep. We're doing some work in the SIM side as well, so you can actually attach SIMs, Splunk being our first one. We're also working on a Google Chronicle one that will allow all of the events occurring from within your probe to shoot out to a SIM of your choice. All right, so I'm going to back over to the repos now. So there's 2 repos I want to highlight. I think these links are in the chat here as well, maybe in the open to all channel. The libraries, actually, let me start with the test one. So here's the test repository. So we've got a number of tests that are open source. We're pretty active in here, pretty much on a daily basis. You'll see our team working in this repository. And we're starting to push as many tests open source as we can. So we're starting to generate a few tests a week right now. So this is going to start gaining steam pretty heavily. Our first couple dozen tests, we're being very diligent about making sure that they're in incredibly well. And then we're going to start ratchet up a lot of our performance. But you can flip through this and see a variety of the tests that we have in here. You can read about how they operate, get use cases, read the code, look at the defamed malware in some of the cases. So we try to be as open and transparent about how all these things work. And this is a great repo to get to know and follow if it is new to you. An example test right here. The second repo to show you guys is the probes repository. So this is under libraries. Now, in this repository, you're going to find all of our different probes. So again, we're pretty big at Prelude on open source and transparency, so we made all of our probes open source. And so to find those, I'm going to hop into Shell, which is where our primary probes are. And I can see we've got a nocturnal and a raindrop, as you saw on the prior slide. So these are the 2 primary probes, depending on what type of system you're running on. And then you can see if you're going to run this ephemerally, it's just a matter of setting an environment variable and starting it as a script. Of course, you can run the installer if you want to go at a persistent level. And these things are tiny. What's the current count on this? Yeah, just over a kilobyte on the nocturnal probe. And you can flip through the code, get comfortable with how that works as well. Same thing with the PowerShell version. All right, let me switch into Terminal. So I love doing demos for you guys on this server because I can actually show terminals. Most of the demos I am banished from showing terminals, so I can never pull out what I'd call the most cutting edge stuff.
We're literally here for the terminal and some reverse engineering. You have to social assembly for no reason at some point. Everybody have assembly.
See, that's the problem with being, complain on my soapbox for a minute. The problem with being a CTO is I demo in front of execs and they're just you cannot show a terminal. So I have to show a user interface, which is good, but also I don't know. It's you can't do as much stuff in it.
Fully understand.
All right, so I'm going to pop open. So you'll find this in the libraries repository. We open source this as well, but we created a CLI. And so this is a CLI that's written in Python. This will work on Linux and Mac right now. We haven't extended onto Windows yet, so you'd have to use Linux or Mac. You can install it via pip. It's also open source. You can build it from source if you want bleeding edge, which I don't advise because we do update it frequently. So staying on the release versions is recommended.
With WSDL, is it going to work on Windows?
What's that?
With WSDL, is it going to... Well, WSL,
yeah.
Sorry.
I've heard it works on Windows through that. I haven't verified it myself, but we do have documented cases of people using it there.
Gotcha.
Yeah. But don't hunt me down if you have a hard time with it.
Never.
All right, so I'm firing it up now. So what you'll see here is it will spin up. It'll give you a little bit of a splash screen. Tell me how many tests I have at my disposal. And then I get an interactive menu that I can work with. And we try to lay this out in a pretty path-dependent way so you can kind of get to know it hopefully a little bit easier. So we're going to start on the deployment of probes. So hopping in there, I'm going to get another little splash screen, tell me about probes in case this is the first time I've entered this. And I can do three things. I can register probes, I can check out results that have come back from probes, or I can remove probes that I don't want active anymore. So going through the registration process, I can give a probe a name, and host name or any other arbitrary name that I want to give. I'm going to take my default, which is just going to default to whatever my local machine is. I can also optionally give it a serial number. So if I'm running on a large number of devices, say I'm running on 1,000, 10,000, however many, host name isn't going to be unique all on its own. So you have to combo it with something if you want to get a unique value. And so we give you another field and kind of wean you towards serial number, although you could replace that with anything else you want to give you more of a sense of uniqueness. And then if I wanted to connect my EDR account, I could give the EDR identifier, CrowdStrike or other. Every EDR assigns IDs to their endpoints, and so I could enter in that identifier here, which would attach it to that account. The last thing I can do in the registration process is I can select tags. So if you've used Caldera or Operator before, this would be similar to like groups and ranges, where you can segment all your probes in your environment based on different criteria. So I'm going to say that this is a workstation, and I'll also say that it is TLP Amber. These are sensitivity levels, so I can tag my probe with a sensitivity level if I want to kind of separate things that way. All right, so this goes ahead and this generates the probe. And it's going to ask which platform. I'm going to run it on my local host, Darwin. And there we go. So downloaded to my machine, generated itself, and dropped a copy on. So over on this shell, I'm in that directory, this .prelude directory on my machine. And just ls real quick, I can see I do have a David's Air probe now available. I can cat it. That way I can see this is exactly what I would anticipate. I'll mark it as an executable so I can actually run the thing. And then I will run it. And what's cool about this version is I did not set the environment variable for this probe because it injected the authentication token into the probe itself. So I didn't need to even set that that token. That's it. So now I've got a probe up and running. I have nothing scheduled for it, I don't think. So it won't run anything yet. So we'll head to scheduling in just a minute. All right, so I'm going to back out and head over to the scheduling because I want to give my probe something to do. And so if I go in here, I can see, hey, verified security tests are designed to run on schedule. A little bit of a difference when it comes to TTPs. If you're used to, again, any of these systems out there or any C2, it's much more manual in terms of I select the thing I want to do. I point it at the agent that can do it. I run it. I get my result. And then I decide if and when I want to do something else. This system's a little bit different. This system's all about continuous testing in order to find the deltas and the differences really at scale, but along a time barrier. So we call these schedules. And so I'm going to go ahead and pop a new schedule or view my existing schedules. We'll start with that. I can see that I currently only have a health check that's scheduled. And that's going to run daily. What daily means is it is going to run this test once a day. It won't run it more than once a day. And so, okay, so I've got one test that's running. Not really a test, it's a health check. So I'm going to go ahead and add a new one. This is where those 15 VSTs that I showed before I had available are at my disposal. So I can see the names of these. A lot of these, if not all of them, are pulled out of our open source repos. And so I can choose one of these. So I can say, hey, will my computer quarantine a malicious Office doc? I want to schedule that. I can do a ransomware test, all sorts of different options. I'm just going to choose the one for now. Let's pull another one. What's my IP? I want to run these once a day. So I'm choosing 2 tests to run once a day. And this will go ahead and generate my schedules. I get to select if I wanted to point these tests at only a subset of our probes based on the tags I set prior. This is going to show me all the tags that I currently have. I can say, hey, only run this on my Amber machines or my workstations. I'm not going to choose either, so I'll skip that. If I skip that, it means it'll run on all my machines, not just a subset. All right, cool. So I added my schedules. If I view it, I should see confirmation that I've got a couple new schedules in there. And now my probe, whenever it runs again, it has the ability to grab those tests, execute those, and you can kind of see that off and running in this particular test. 2 tests ran, logs print out to standard out, and I can see these exit codes telling me what occurred within the test and what it came back with. So 101s meaning these things ran to completion, but they should have been stopped. And I'm actually running, make sure it's running. Yes, I am currently running Falcon. And so this is a case of me running an EDR on my device, and I'm dropping a signatured Excel, MSF Venom in this case, a signatured file that an EDR or AV should catch just based on pure signature. And in this case, it's flying by and writing under the covers. A lot of different reasons for that, but these are the things that we like running these things continuous nature, so you can see, is that actually occurring in your environment, and is it changing if you make config updates or tweak different settings and so forth. Now if I back out and head back to my deployment of probes, I can jump into viewing the results, where I can grab all the probes that are currently in my network or my account, and I can click through and I can see each one of the results that occurred on it. So not a whole lot in my case, I've only done 2 things. All right, so that's your kind of deployment of probes and how do you schedule things and back and forth. So the concept here is as quick as possible to allow you to generate probes on the fly, run them across an n number of devices, and then schedule things, and then step away, right? I could step away and come back in a week or 2, and I should get these 2 tests running across all my probes every single day, and then in 2 weeks I can check, a week or 2, I can check what my aggregate results are and start to make a decision of what do I want to do now that I've learned this stuff. So I'll pause there before I jump into a code editor.
Makes sense. I guess no question in the chat, so everybody's happy with the explanation once more.
Cool. All right, I'm going to pop into VS Code here and see what we see. So I'm in, again, the .prelude directory that gets created when I install the CLI. And inside of this directory, I have the probe that I created, but I also have a workspace directory that contains all my tests that automatically gets dropped in here as I'm developing. So I'm actually going to start the CLI from within Visual Studio now. So when I do this, it becomes much more integrated with my development workflow. So I'm doing that so I can hop into the Developer Hub. Inside of here, I get really CRUD operations. I can create tests, I can upload them, I can download them, and I can just purge them all together. And so to kind of highlight how this would work, I can create a test. Defaults to does my defense even work is the test name. So I can give my test a name. I can classify it whatever system I want. So attack, CVE, one of the Prelude rules, whatever you want to do it. So we'll call this T1015 MITRE attack technique. And this is going ahead and creating this new test for me, which if you caught that, it dropped it in here. At which point I could install an actual Go linter in my VS Code to remove the red squigglies. And then I can actually write my code from within here and test it all inside of my local environment until I'm happy with it. Once I'm happy with it, I can upload it, which I'll just do now because this is a template of a test that will work all on its own without any modification. Now, a test needs to be uploaded before you can schedule it. So what this does is it actually uploads it, and in my case, I have one custom test, so that's all my choices for it. What that does is that it compiles it and uploads it to S3, which allows you to have a place that you can now download it. So it's essentially a staging location with the compiled version of this. And what's cool about that is you can have you can write the test and test it all locally, and then when you upload it, it will compile it for every applicable operating system. Basically, every version of Windows, every version of Linux, and every version of Mac. It will create compile versions of those that you don't have to self-manage. Now, when a probe connects in and asks for a test, it will automatically be given the operating system, both the operating system and the CPU chip, that best matches out of the collection of tests that have been compiled. So, for example, if a Linux x86 probe checks in, it's first going to see, is there a Linux x86 version of this test ready for me to run? So it self-selects the best version, and we wrote tests in Go by default, so we could actually utilize that automatic compiling of all these different platform type of technology. So at that point, I can actually go and I can schedule it. And I just wrote this new test. I can find it in my list right here. I can say I want to run this one once a week. I'm going to run this only on my workstations. And done. And so I can see the note here, probes check in every few hours. By default, they'll check in every 4 hours, which you can override if you want. But they check in over HTTPS and check for new tests. If there is a new test, it will grab it. In this case, it's going to grab this new test I just wrote once a week. And again, it will self-select the best version based on platform and chip. So lots I can do right here within my editor. The last thing I can do before I jump into the UI version of it is manage the account. So every CLI, when you start using it, is actually part of your own account that gets created on your box. Now, what you can do inside of your account is basically extend it into a multiplayer team if you want. And so you can have a number of users on your account. So if I wanted to jump in and see who I have on top of my account at the moment, I have two people. I have one called myself, and I'm an admin, and I have one called a user called registration that has service level permissions. There's a permissioning mechanism built within the system that you can read about in the docs, but basically you can create users that have various levels of powers that can do different things. Service being one of the lower ones. Basically, it can register probes on your account. So I can go ahead and create users at any point if I want to add new folks. Now, if I create a user, what it will do is it will generate a new set of account credentials, account ID and token, that I can then send over to anybody on my actual red or purple team. They can load it into their CLI, and then they can collaborate with me. They'll see every test that I write. I'll see every test they write. We'll both be able to see the probe results and so forth. I can attach my CrowdStrike account in my case or my SIM, and then purge the account. And the last thing I want to do is I'm going to hop back to my normal shell.
Quick question before you get back there.
Yeah.
These files, right, technically they can end up being pushed on the other side of the house, right? AKA whatever target you're running, those test scripts, right? Like the
Exactly.
Go file. But they get compiled on the endpoint or before you actually you send it to them?
Yep, so they get compiled before they hit the endpoint. So you write the code, wherever you want to write the code, you upload it. The uploading process hits Prelude's API. We compile it for all the different architectures for you.
Yeah, that's
and
why
then
it was
it's in the S3 bucket that you pull from.
That's literally why I was asking, because the import is actually requiring you to have access to the internet. So I was wondering if you have an endpoint that doesn't necessarily have access to internet, it's probably not going to work. And I guess that also brings another question. Do you have any way to actually get the information from a system that does not necessarily have access to the internet? Can you do like the equivalent of SMB beaconing and stuff like that?
Yeah, so not yet on that. We're actually working on, we're not far off on a kind of an internet-less version of this that will allow you, it'll be a little bit of a tweaked version, but it will allow you to, instead of having an S3 bucket that the tests are being served out of, be able to store those in any type of file share. So think like, hosting your own S3 bucket, but that's still on internet, but maybe it's inside of an intranet. but you could also think like, hey, I've got a hosted file share or admin share or some other location that is file share based, directory based, and then you'd be able to host that and tests could read out of that.
Got it. Makes sense. Thanks.
Yep. All right, yeah, let me flip it into the UI version. So all this stuff we just did in CLI, this is the part that nobody ever sees except like people like you guys. And so this is what everybody else generally sees. You can open up the account inside of a web browser, which will give you basically a visual version of all the results, what's occurring, and so forth. Everything that you can see here is available in the CLI. Quite a bit more is available in the CLI. But this gives you a graphical interface that you can start to hopefully understand things, I think, maybe a little bit better, especially as things go from technical teams and all the work a technical team may do from a CLI. Think of this as the bridge into the executive group that they have no idea what we're doing in terms of writing tests, but they like the graph here, right? And so what I can see is a timeline of the last 60 days by default. And I can see the different tests that are running and succeeding and failing over the course of that time period.
And when you say failing in the sense like host was unreachable, or the test case based on the ID or the status code that you show us earlier?
Yep, the latter, the status code.
Got it.
Yep, there is a case for things that are error or unreachable or timeouts or like exceptions that will show up as well. I don't have any on screen, but there's 3 categories a host could be in. Either it's protected, everything that you've run is coming back as like getting caught and is correct.
Right.
You have unprotected, which is like a test should be getting caught but isn't. And then you have an exception, which should be your lowest amount of things, which is things like host is unreachable.
Got it. But is it part of the fail, or it's just a different type of color or something like that in the graph?
It'd be a different color entirely. Yeah, we show it as a yellow.
Got it.
And then below here, what you're seeing are computer-generated, what we call insights, which is when we load this visual, and you can do this in the CLI as well, it's just easier here. What we do is we crunch through all of the different results in aggregate and try to figure out what combinations of things are causing the most issue. And then this is a priority ordered. So in this test data that I have on screen, my biggest issue is this particular test on my Darwin ARM64 endpoints. It's failing 100% of the time, and I have 10 of them, which is telling me if I fix this one issue, it's going to fix, my biggest issue, basically. Now, if I'm curious about what these are, I can click on these. And this is then going to filter into a view where I can see each one of the devices that is in that category. And then when I click on it, I can get an event stream of every test that ever ran on that particular device and a couple other odds and ends when it comes to details. All of this is API-based as well. Both the CLI and the UI are hitting an API. Which is obviously completely codable, so you can do whatever you want with that. And I'll highlight in GitHub, in the libraries repository, inside of Python, because I know on the security side we always do a lot in Python. There's an SDK that you can import or install via pip that wraps the API and allows you to code against the API pretty easily if you are somebody that likes to do that. All right, cool. So I'm going to pause there. I think that's, pretty good timing to wrap up. Any questions or thoughts from people?
All good. Yeah. And just, I guess, a quick question. When it comes to Prelude, you have, a free tier and a paid tier. This is all part of the free tier, or it's kind of limited?
Yeah, everything you see is part of the free tier. So we are aiming to really not hide anything when it comes to what we do, transparency or being able to use things at that free tier. Where we're leaning in is saying, hey, if you're going to use this at scale, and right now our scale is around 100 tests a day, or a number of endpoints that is like large. You're going to start to run this at scale, then we want to flip you into the paid tier. But we tend to be very, very low on pricing when it comes to comparison to things like the BaaS market and so forth.
Gotcha.
yeah, if you want to use this, run this on, 5, 10 machines and run a number of tests every day. You can run this, free of charge, use all the open source stuff. Our team pushes stuff every week. Really, we're trying to get this in the hands of people to be able to run this for free inside of their Purple Team environments at the scale that they run. And when you want to move it from Purple Team to the whole organization, at that point, it's like it makes sense to move to paid.
Yeah, that's for sure. Especially if you're targeting your own customer as a company that perform purple teaming or anything like that, right?
Exactly. Cool. Yeah. Any questions about either this? I'll set Prelude. Me in particular. Happy to answer anything you guys have.
How tall are you?
I am 6 feet tall on the dot. Pretty average.
Fair enough. I guess now there's some people typing. But yeah, honestly, like the first video that you did for Prelude, it was pretty straightforward in the sense that I think the UI is pretty clear and straightforward. I guess it's always a matter of, playing with the actual scripting and all of that. But yeah, the only way to actually thoroughly test it is to actually play with it. And that's funny because when I was first approached by you guys, I had a conversation with my boss about, hey, this tool can be interesting, as part of some client offering where we automate some of the task case. And like, I see this more as a, detection is not what we care about. It's just to know how good or bad we are. So if you want to, find the path to your crown jewels, that's a typical red team or anything like that. But if you just want to know how good or bad you are when it comes to detection, that's probably something that can be automated with that. So that's definitely answer the question from my perspective.
Totally. Yeah, it's one of those, like, it's really interesting. So, like, if when you really sit back and think about, like, how do we determine if we're safe or not, right? And if I'm an individual and I go to Best Buy and I buy a laptop, and, like, the very first thing I need to do is buy an antivirus for it because I bought, some dumpy Windows machine that, like, needs all the protection I can get. My decision of picking out an AV is actually not very easy. How do you pick one, right? People tend to pick it based on, like, favorite color or whatever they saw, in marketing materials. And the funny thing is businesses actually operate the same way. And I can speak from the experience on the government red team side, like, governments act the exact same way, which is incredibly scary. And so what we're trying to do with this system is just like you said, it's kind of like a traffic light system. Run this thing at scale. You just spent however much money on defensive protections. We'll run this thing at scale at a fraction of, the cost and determine, is the thing I just bought actually working, configured correctly? Is it capable of learning? Is it, going to be a good for my future and all that sort of stuff?
Makes sense. So I guess a couple of questions. How long have you all been working on this?
Yeah. So the funny thing with this is we actually started this at the same time as the company getting off the ground, really. So Spencer, myself, our CEO, when we got Prelude off the ground, it was with this vision in mind. So we did all sorts of iterations between August 2020 and July 2022. So that 2-year period, we actually did a significant amount of iterations, but kept it all in-house so we could try to really solidify how this was going to go at scale and so forth. In July of 2022, so only about, 7-8 months ago, something like that, we moved it into official development, which means we took all the prototyping, all these things that we had developed before but hadn't released, and we put it into a development pipeline. And between July 2022 and November 2022, so only a handful of months, we pushed out the very first version of this online. And since November, we've been doing releases on a weekly basis. And we're getting ready. We're very close. We're a couple weeks, I think. Sometime in April, we're going to release our version 1.0, which is the version that we intend to start scaling with.
Makes sense. Someone else asked, I haven't seen much development on Operator. Has the focus shifted to detect now at Prelude, or Operator is still actively developed by another team, or just...
Totally. Yeah, so we're actively supporting both right now. So we look at them as two separate tools that each in today's world have a value add. We're not putting as much emphasis on future development of Operator because we put so much in the first 2 years and got that to a pretty stable spot. So we're doing bug releases and some small feature releases on an ongoing basis. but we're pretty happy with the stability, so we're not doing much in terms of future dev. What we're doing on the detect side is a tremendous amount of future dev to get it into that 1.0 and beyond state.
Nice.
So think pull operator if you want to do a manual security assessment, and pull detect if you want to do a continuous one, and that'd be a good mindset to kind of think of the two tools.
Nice. So apart from that, other people were saying that they only buy EDRs that have pretty ads in the airport, or EDRs company that sponsor major sporting event. If it's not the case, they're not interested. I generally don't know which one it is. I'm assuming that you probably referred to Super Bowl and stuff like that. Funny thing, since I'm in Canada, when you watch it, you don't see the ads because they didn't pay their fee or whatever. So you just see garbage ads. So
Is that for real? I didn't know that.
yeah, yeah. Unless maybe if you go with the streaming service or whatever. But if you just watch it on TV here, yeah, you're not gonna get the fancy ads. Poor
Wow.
Mercedes. They put a CrowdStrike logo on the Mercedes. That makes me feel sad.
See, I think the thing with like vendors in general, not to like pick on like an EDR or even like anything on the endpoint, I think the thing that especially I've noticed over my career, is I've watched like enormous companies that are in not cybersecurity industries, like retail or, home construction or all these different things, and they have enormous, enormous cybersecurity teams, like organizations that shouldn't actually have security teams but have threat intel departments. And it's actually insane when you think about it. And the reason is companies don't trust their vendors at all. And so they're building armies of cybersecurity people to just verify manually that these tools are actually working, or as a backup to the tools. And we need to start to shift, I think, as an industry, more of the responsibility of doing security, at least the automated forms of defensive security. More of that responsibility needs to shift onto the vendors and off of companies that are buying the products. And in a large way, that's what we're trying to do with Detect, is start to shift that responsibility, so vendors kind of are put in the spotlight and are forced into creating better products that create more security. So security teams at organizations can actually focus on harder things to automate in more specialized cases.
Yep, 100% agree with you. But yeah, and don't get me wrong, this whole EDR game is also extremely complex. I'm not gonna, comment on that, but I think there's also part of it that it's, a money-driven business, so they don't necessarily have to detect everything, because all they have to do is detect enough so customers still pay for the product.
Exactly. Yeah, it's a hard game. Like, I like being on the offensive side more because it's in my mind quite a bit easier. But defensive stuff especially on an endpoint, that's a hard game to be in.
Yep. So we have another question. I was wondering how you manage this at scale on the blue side. Let's say you run the probe with the VST dropping a Maldoc on 1,000 endpoints. Would you prefer probably get many alerts in and some environment that could show pop up for the user? How do your customer manage that? I guess that's a good point, because the engine detect that, let's say CrowdStrike detected, but they probably also get the alert on CrowdStrike house. So is there a way to kind of prevent the test alert on CrowdStrike side or something like that?
Totally. Let me talk while showing a screen on that. So, yeah, we're actually working with a pretty large customer deployment on this particular thing right now. The short answer is we can customize it to what makes sense for you, because everybody's a little bit different. So to show, I think we've got that in here somewhere. Blah, blah, blah. All sorts of common questions that we get that are worth reading. These has something to do with a large number of alerts occurring. Oh, there we go. Won't detect fire off lots of SIM alerts. All right, perfect. So the goal is yes and no. So we want a large number of alerts to be fired off, so you can actually test those things and be expected, but we want them to be managed by default. And so what you can do is, when you attach your SIM to your account, you can have a specific tagged identifier, which is really up to you. get sent off with every one of the events that occurs, so you can organize them separately within your SIM. We can also do this on the EDR side, so if alerts are coming out of either your SIM or your EDR, we can go with that methodology. And that allows us to either automatically quiet the alerts and put them into like an informational stage, or you can take those alerts and actually act on them. So you get a little flexibility there, but basically the answer is we can customize it based on where your alerts are coming from and how much effort you want to put into detection engineering as part of your detect usage.
Got it. Hopefully, yeah. Apparently, you answered the question.
Cool.
Wait, and that's another thing too. It will be nice that EDR can actually come up with a test code or event ID that you can actually use to tag alerts. But I guess it also open potential ways for attacker to pretend that this is a test alert and ignore it kind of thing. But it would be nice if they have something. It's like this binary which is signed, confirmed to be legitimate, is issuing alert, ignore them kind of thing. But this is something that I didn't see being implemented yet.
Yeah, exactly, and that's the benefit of the API being over on the SaaS side of the fence is when an event gets triggered off and it gets sent to us over the API, we're able to then take that information and silence it or highlight it for you in the alert and tell you what came from a verified signed test and things that maybe somebody's trying to trick and did not come from a verified signed test.
Nice.
Yeah, I'd encourage reading through some of these common questions as well, because I think that there's a lot of these that are pretty interesting perspectives. The team here put a lot of thought into like all these sort of different areas to try to create a system that we can actually we really believe we can actually scale this from purple teams doing testing on small numbers of devices to being able to have a security team that writes a test and then runs it on all 100,000 endpoints at an organization, which is something we have yet to see any other thing do, and we really want to try to push in that direction.
If I may, it's me ask the question. I think that's really good. Like you said, like that's the vision, and I think the challenges is integrate this with the blue team and do this exercise maybe on a daily or weekly basis and not taking too much time, right? In the workflow and focusing on what's really important. Because I can see the challenges doing that. Like if I try to tell my clients, okay, let's deploy this everywhere, and your SaaS is going to have to handle 10,000 alerts a week and trying to, that's like from the tools. So where didn't trigger, you need a feedback loop with them, sit with them, go through all of this. So manual labor. So there's a lot of challenges around that.
Totally. Yeah. And that's where, you've got two options. You've got the automatic and the manual. So what we're doing with a customer right now is going more on the automatic side, which is automatically triaging and handling all the things that come from us. So it is bucketed into a separate area that they don't have to look at if they don't want to. That would be our advice for anybody trying to go with that. That just doesn't want to deal with the alerts.
So they need a SIM for that, right? So that makes things easier, because you're tagging your events and they can correlate that at the SIM level.
Yep, so we correlate it. We automatically correlate it for you and say, yep, this one came from us, ignore it, this one's verified. And you still get the event, but you get to see that it was tagged as being verified.
That's interesting. We have a lot of clients, they don't even have a SIM. They have a lot of EDRs. Sometimes they have a SOAR. And not much of them invest in a SIM no more. So I was wondering, for these type of clients, how can we implement this type of solution at scale without the SIM?
Yeah, so we can do the same thing with EDR. So alerts coming out of an EDR, we can tag those and automatically triage those. So we've done that with CrowdStrike is a pretty good example. And we've done SIMs. We haven't done a SOAR yet. I don't see why we couldn't. It hasn't come across our pile of things yet.
All right, thank you.
Mm-hmm.
I'd like the record that shows that K3 actually did a terrible wordplay with Prelude should be sponsored by Honda. So I guess
that'll be in our Super Bowl commercial next year that we totally are going to run.
Yeah. And I don't know anything about car, but if I remember correctly, Prelude was actually a Honda model, right? So that's probably the joke behind it. So.
It's quick.
So let's reach out to Honda and see if we can get some. But I guess that's what it is, right? I know two things about car. One, I don't know anything, and second is they sometimes have four wheels. That's about it.
Well, appreciate you guys having me. Really, this is fun. I love being able to like live demo and pop open terminals. So I appreciate you guys hearing me out today.
Always a pleasure, and you're always more than welcome to stop by.